Hi, I'm Paul Kreischer. For the past quarter of a century, I've worked to create more energy efficient homes and buildings. I'm fascinated by the technical aspects and cutting edge ideas from people who are pushing the boundaries in their projects. Equally important to me is the why behind the plan. What's the motivation for these individuals to make the effort, take the time, pay the additional money to take on sustainable and regenerative design and construction in their projects? We're going to take you on a journey to explore 3 unique construction projects: a church remodel commercial building, an innovative single-family home, and an exceptional multifamily building. Explore the design and the desire for each one to be examples of creating the buildings of tomorrow today, and to leave the world a little better than how they found it. When we recorded this video, we were 4 months into the US response to COVID-19. Shortly after restaurants began to open, but steps were still being taken for social distancing, and you'll see me and interviewees occasionally wearing masks as we move through these buildings. These precautions were done to protect the well-being of others and reminded me as to how we are all connected and need to truly care for one another as we move through life. This connection between all of us is the fundamental reason for our videos, to showcase buildings which provide for our and all creation's greatest good by using less resources while delivering optimal performance for the occupants. May we all be well. First Universalist Church members in Denver are a great example of living their values through the renovation of their building. The whole congregation got together and decided to shoot for zero emission, not an easy or cheap goal, but one they truly believed in. Let's head inside and find out more from these amazing people. We're talking to church members John Bringenberg and Milt Hetrick, Reverend Dr. Elaine Paraslua, and Communications Coordinator Jessica Montgomery about their goal to design a zero carbon footprint building. And while this green light has nothing to do with sustainability, it's a very cool design feature. Find out what it is a little bit later. So Milt, if you'd be so kind, I mean, you have a brilliant mind in applied engineering that you did in helping this project come together, but tell us a little bit of your background, all the good street cred that you had through the schooling and work that you've done before quasi-retiring and then working on a project like this. No.
Well, I got my engineering degree in aerospace, and I spent probably the first 10 years in aerospace. Left the industry and went into the oil and gas field for about 3 years. Was involved in some oil shale technology. Then ended up going back to aerospace where I retired. And in the meantime, I also got a degree in physics. So little did I know I was going to be applying it to a church project.
And you did great work with it. So related to the church project, obviously, can you tell me briefly why you, the congregation, the people working on this, chose to do such a high-performance building instead of simply meeting code, like so many other projects?
Sure. This project, we have to kind of go back and recall that it got started around 2015. And at that point in time, the global community, as you know, was becoming very concerned about the climate crisis, global warming, and that was the year actually of COP21 and the Paris Agreement,
right,
where the global community made an agreement to reduce greenhouse gas emissions and limit global warming to 1.5 or 2 degrees.
Right.
So that was the big picture that was going on at the time this project got started. Now, if we come down a little bit, our religious denomination, the Unitarian Universalist Association, they had published what we refer to as statements of conscience. Within this church, we had a small group of environmental activists that we called ourselves the Green First Task Force. We were concerned about the growth of our congregation and that we needed more space, more classrooms, a bigger sanctuary. And so we initiated a building renovation project. And one of the members of our task force, John Bringenberg, who got himself positioned on the building committee, right, and made sure that we had sustainability perspectives as design requirements for this renovation project.
You know a lot about this building, about the whole process, but what I'm really fascinated by in this project was the why people came together to do this great project.
When you have a church community, you have a unique people environment to make decisions of this kind. We, of course, have to think about the economic impacts of energy decisions when we're redesigning this building. But being in a church community, you have the opportunity to bring in another dimension, something that maybe it doesn't exist in a normal commercial business, for example. And in our case, that's what we call our seventh principle.
This amazing building is a manifestation of many beautiful principles and values that come from the Unitarian Universalist Church, and I'd love to learn more about that.
I would say the general value of Unitarian Universalism is to live your faith, to live out the principles, and we have 7 of them, and they are about democracy, about how you treat one another, the dignity and worth of every human. But the one that's important to this project is the 7th principle, and that one is we are all part of an interdependent web of all life, and that we are to recognize our equity with all other beings, sentient and not, and the earth, and to care for the earth as stewards.
Well, early on, we did our homework and tried to define what I'll call the harm that we were doing to our planet, and quantified it in the context of tons of CO2 that this facility was introducing into the atmosphere. And what we learned was kind of shocking. We learned that because of the electricity that we bought from our utility company, Xcel Energy, they in turn were dumping about 50 metric tons of CO2 a year into the atmosphere, and we were buying natural gas from them and burning that on site in 10 different gas furnaces and dumping ourselves another 50 metric tons into the atmosphere. We also were aware that there are alternatives to doing that.
Can you tell me a little bit about the story and the process of how people came together, especially around the funding portions of this project, to make it happen? Because it's a great story.
It is, yes. We had a capital campaign for the building renovation well underway, and working with the architects, when a member-driven initiative, a very bold one, came up to add a sustainable energy system, and also add the cost for a sustainable energy system.
It's challenging for several reasons. First off, it added more than 10% to the cost of the total building project.
And being understandably debt avoidant, the church just asked, can we go ask for additional gifts specifically for the sustainable energy system, and then close the gap as needed with a member loan.
So the community, as I heard it, came together and said, we're not going to try and get the maximum dollar out of the church that we can. We want to give a gift, but we need to get our money back, plus get 1.5%, you said, interest on it?
Right.
In exchange. That sounds like a beautiful win-win.
Yeah, we thought that was a rather unique approach, because going in, the first response we got from just about everybody was, we can't afford that.
Yeah, member-led, member-driven effort. We exceeded our goal in the additional member gifts, specifically to add the sustainable energy system to the building project. And then with the remaining funds, members came together and formed a general partnership, the 7th Principle Partnership.
Cool.
And that bold move paid off. We were able to see the project completed.
You were heavily involved in many of the technical aspects of this project. And I had the pleasure of working with you guys and being involved with doing air tightness inspections and blower doors and things. But can you tell me a bit about what you chose to do, let's say starting with the envelope of the building.
Okay, great. This was a retrofit, so there was about 20% new square footage added to an existing building, which was restored and rebuilt. But in doing so, we were able to get nearly the entire building envelope with new insulation, including a skim coat of foam on the outside, bat fiberglass insulation, to bring us to about an R30 value in the walls.
Which is great.
We have a flat roof for most of the roof on the building, including the original parts of the building. And we were able to really beef that up. And we went from having about 2 inches of solid foam insulation to having about 6 inches, bringing us to an R value above 50.
Which is really amazing, because yeah, your beginning levels, you were closer to like an R14 or R13 maybe, and yeah, to be above R50 up there is just outstanding.
In the design of the envelope, airtightness, making the building tight was really the first parameter, and the R value was really a secondary parameter. We employ, for the first time in this building, 5 ERV units, and those ERV units work hand in glove with the envelope being as tight as it can be.
Yeah. And one thing I can share, since I did the testing, is that the building came in at a test level of a 0.188 CFM per square foot at 75 pascals, which is amazing, because code for new construction, not a remodel, but new construction, is 0.4. So you were less than half, as far as that standard goes for new construction. So you guys did some really good stuff with that part of it. If I may, I want to ask you to get a little more in depth about the ground source heat pump system, the technology, because it's a new enough technology. I mean, it's been being used in the Midwest for a decade or more, and in other cases, but it's still an exception. We don't see it in enough projects, and so you were quite innovative to bring it in.
Well, if this were a new construction and we didn't have a parking lot paved and landscaping in, we probably would have selected a so-called horizontal installation of these heat exchange pipes.
Right.
It's the cheapest way to do it, but
And
because...
how shallow or how deep would that have to have been?
Well, they probably go down 6 or 8 feet.
Okay.
The alternative is to drill 5-inch diameter holes down and insert black plastic pipes in a vertical manner.
The materials that you have in this building, the pumps, the piping for it, even the air handlers themselves with the water, connecting back into the air handler from the, ground source loop field, all look, and they are just really off the shelf. I mean, they're just common products. There's nothing that's like incredibly innovative with that part of it, which is great. Makes it easy for repairs and things like that going down the road. So you were an integral part of having solar PV, photovoltaic, put onto this building to power a tremendous amount of this building's need for energy. So can you tell me a bit about the system you chose and how much it's helping offset right now for you guys?
Yeah, thanks. We knew that being able to generate electricity on site was key to our goal of having a zero carbon footprint building. We planned a system that was designed to cover approximately 100 to 105% of our projected energy needs.
Yeah, that's great.
And we used about, I would say about 80% of the space on the roof to accommodate that. So we knew that we had a little bit of room to grow if needed, and that we have a system that is about a 58 kW system. It generates between, we'll call it 80 and 85,000 kilowatt hours of electricity per year. And we're now finding, after over a year of usage, that we may be a little shy of 100%, and we have the space on the roof to be able to increase the size of that system to make sure that we are at 100%.
And that's being given serious consideration, that you may add to it in the near future?
That is correct, because we set out and the congregation agreed to a goal of being carbon neutral, and that's part of that equation.
So John, tell me what this great performance boils down to in dollars and cents for you on your utility bills on an annual basis.
Our historic bills on the building, which was a little smaller before, was over $20,000 per year. We are now spending about 20% of that amount with the new systems in place, and I would say that the vast majority of those charges are considered base charges and demand charges.
That's fantastic. That's really fantastic. So there's some beautiful things that you did with daylight in here.
The architects that helped design the building placed a high value on daylighting and did their very best to be able to bring daylighting into every common space in the building. That was very challenging in the lower level, which prior to the remodel was a typical church basement with very small edge windows. But they were successful at getting some daylighting there. Some of it comes through sonotubes from the roof. Some of it comes through some clever arrangement and enlargement of windows in the lower space. But there are other places in the building where daylighting is even more dramatic. The space that we're in right now, we call Friendship Hall. It's a gathering space. And then our sanctuary has maybe the most important architectural feature. We call it the Oculus. It beautifully brings in light with north-facing windows, and it really does a great job of lighting the whole sanctuary space. For this building, it's our wow factor.
I'd love to hear from you because I know it was I see it as being part of your vision to be very conscientious about reusing and using recycled materials in the building. Can you tell us a bit about those elements, like what got reused, what parts of the recycling elements that you're proud of?
Sure, the chairs are one of many elements that we reused. So the green chairs that you see were our original chairs in our sanctuary, and we simply cleaned them. And as much furniture and other elements we could reuse, we did. In our hospitality center, the ceiling panels, so that whole space was a sanctuary, as you may know, and that was the entire ceiling. And so they took them down and carefully preserved them. There are other materials, right, it was probably much more work to do the demolition in order to be able to preserve them.
I think if I was going to pick one thing that symbolizes the intentions and the fulfillment of those intentions very much is the beauty of the wood.
In the sanctuary, we have a dramatic effect from beetle kill pine wood, which is an inferior species, but there's a lot of it.
So often people think if you're going to use recycled or you're going to be environmentally sound, it's going to be ugly. And I don't think you have to compromise anything. And this building is a statement of the beauty that can be created being environmentally conscious. And I think that's the most outstanding piece for me.
You literally wrote the book on this project, and it's a fantastic book with great graphics, great data details, great descriptions of the process about how the community came together on the financing side as well as the technical decisions. And I know you have this available through the church, but we're going to have it available at our Heart of a Building website so people can get to a link.
Thank you. And it was a team effort just like this project was. So we had this small group of dedicated people, and I just happened to be the reporter and document it. But we did go through a lot of lessons learned, and it wasn't all, how should I say, roses along the path. So we wanted to document some of these things that we learned in the hopes that it would make it a little easier for the next group that comes down the same path.
That's a beautiful gift. Remember that green light from the beginning of our story? It's from a solstice window across from the Oculus, one of just a few dozen in the United States. 4 times during the year, a small light appears during solstice and equinox events. A beautiful touch on this awesome building. For every effort that brings change in our world, a champion is required. A person or persons who see the vision inside of themselves and then shares it with others. In the case of First Universalist Church, it was a community of people envisioning the need for their building to serve as an example of a structure that is in harmony with nature. And they succeeded. A huge thank you to First Universalist Church for sharing their beautiful remodel with us, taking us through the design and their heart-centered reasoning behind it. You can learn more about the technical details about this project by watching the technical video and seeing documentation at the Heart of a Building website. Now let's head to a single-family home that's truly on the cutting edge of efficiency. When it comes to innovative single-family construction, Con-Frank is at the top of the industry. These all-electric homes, both net zero energy and net zero emission, are truly built from the perspective of demonstrating independence from fossil fuels. Passive solar design, insulated concrete forms for construction, Energy Star windows, ground source heat pumps for heating and cooling, and so many other cool features show just what is possible in the future of home building. We're lucky enough to get a tour from the owner of this impressive home. So let's go take a look. I need one of these. We're talking to homeowner Wes Geary and builder and designer Con-Frank about what makes this home so cutting edge. And what do a set of keys have to do with testing the envelope in a home? Find out a little later in this program. Con, definitely want to pick your brain on many things today. This amazing house that you designed, built, it was your vision to put this here with such great features, passive solar features, great insulation, great air sealing. Why did you choose to design and build a home with these features? What was the driving force for you?
Well, I've been in the business since 1978. Built a lot of different things for a lot of different people, and we've explored a lot of different types of equipment, types of processes. This is an accumulation of all of those things kind of put together.
As I've known you, Con, you really, the title or term I put to you is you're an inventor, somebody who invents things in buildings by experimenting and doing things with them. Tell me a little bit about, going back to when you were a young lad, what did you do? Who were you? Were you the bane of your parents' existence, taking apart the toaster and doing stuff like that? Or what did you do to learn this stuff?
I've always been pretty curious, and I grew up on a farm. It was a pretty big farm, and so when my folks would go to town, we would find things to play with. And so we took took things apart. Sometimes they got all back together again, sometimes they didn't. Started building 1978 is when I got my first contractor's license and went on my own. And we did a lot of energy efficiency stuff. We did a lot of solar.
Why'd you do a lot of energy efficiency stuff in 1978?
We had gas shortages,
Okay.
gas lines,
Okay.
all kinds of stuff like that in the early 80s. I grew up in Dickinson, North Dakota, where we had an oil boom going on, and people came in, and it gets cold there. And so some of the people came in were engineers for the oil companies, and they wanted better than normal housing. And so we built earth berms homes, we built super insulated homes, we built all kinds of stuff, and that was before we knew about the indoor air quality, and polluted the hell out of those poor people, and had to go back and correct things and do whatever as we learned.
I've always been interested in modern homes, modern technology, modern new things. And so when my Aunt Maxine was here visiting from Texas, we went and looked at some really expensive homes because just for fun. And some of the homes down on around First in Quebec were being built with the geothermal and things like that. And the people were happy to tell you all about the features of the home. And they were $1.4, $1.5 million homes. You know? Well, that's really nice, Get out of here quick, But I got interested in this home again because it was in the neighborhood. It was so different. And watching it being built, I was just always curious about it,
Yeah. So how did you and Con finally connect? Did he bump into you? You call him? When
the home went up for sale, when it finally finished, I got the nerve to come up and come in. and look at the house, you know. And they had an open house one day, and Con was here. I'd never met him before. Told me so much, it was over my head, but I could tell he was really passionate about, number one, the environment, but number two, people's health. You know, he was really concerned about people's being able to breathe well in a home, you know, be comfortable, but also live economically. You know, he was just passionate about, you know, all the good things you could do with a house.
So Con, in the case of this home, if you don't mind sharing, it can be ballparkish, but a typical home is about $450,000 in this size. Where did this home come in for you? Or maybe the other homes, maybe not Wes's home, maybe the other home across the street that you built exactly the same way. How much did that sell for, if you can share?
I think this one was 5.25, right, Wes? Yep.
Okay.
The one across the street was just under 5, but we didn't finish the basement.
What you did in this home, we're taking some old principles that have been around for a long time. Mesa Verde down in southwest part of Colorado to use passive solar was there, but you also used a lot of advanced technology to what you're doing. So when you started building the home for the envelope, so the thermal envelope for it, tell me some of your choices and why you chose them.
We evaluated the conventional construction, which everyone has done for many, many years. We evaluated some of the SIPS panel stuff. We did the ICF.
So an ICF insulated concrete form, it's going to have, in your case, it's got 4 inches of foam.
2 5/8 on each side.
2 5/8, okay, on each side, and then concrete in the middle.
Yes.
Poured in on site. Yeah.
Right.
So
And we're insulated concrete forms all the way to the trusses. We have high-heeled trusses. And so we sealed all the trusses from the concrete up to the baffles, up to the airspace for ventilation in the attic with foam. So that is all sealed because that's the biggest culprit in air infiltration in the house, heat transfer and air infiltration. And so we kind of covered all these little details. I've been working with energy raters like yourself and people through the many years, and with their cute little infrared cameras, and when we do the studies and we do the air blower tests, you can see many different things over the years.
Right.
And so we've pretty much put all that together in one package.
Hey, Paul, come on in.
Hey, Wes, thank you so much. Good to see you again. I've come back following the interview to do a quick blower door test, which is always done with energy audits and more commonly done for energy code compliance these days to quantify the air tightness. And today I'll do it for Wes's home. So if this home had been built to code, it'd be like 2,500 instead of down in that range. You know, tell us about what you did with the windows and how you decided to orient the windows and orient the house, really, for the passive solar benefit.
We set up the houses in the whole subdivision to best access our southern access. We use triple pane windows with argon filled gas. We use special window bucks compared to what most ICF builders even use. We personally build those and we insulate them because a lot of them will put the wood window bucks in, and in 25, 30 years from now, all that condensation has collected in there. You slam the door, the window falls out.
Exactly.
It leads to a lot of thermal bridging. It leads to a lot of air infiltration around there, which we've eliminated.
You happen to know the U value of the windows that you installed?
The fixed glass in here were 0.20.
Okay.
The operating glasses were like 0.21 and 2.3.
Extremely good. And then, as I understand it, you did some different solar heat gain coefficients with the glass on the south side versus other sides of the home. Is that correct?
We very specifically picked glass that will allow solar gain for us in the wintertime.
Nice.
And so we can have quite a bit of solar gain, BTUs of solar gain in the wintertime, and in the summertime, the R value or the glass reflects it off, and we don't get much gain out of it.
I'm going to guess, tell me if I'm in the ballpark, I'm going to bet the windows on the south side are letting in 55 to 60% of the sun's?
56.
56, good. I'm in the ballpark. That's good. Good. And then on the other sides of the house, probably only 25, maybe 30%?
I think we're at 31 or 32.
Okay.
I like the way that they designed this side of the home to be cool in the afternoon. So my patio is such that about 4 o'clock, 5 o'clock, there's a shadow there.
Right.
Where the way they shaded the home. And I said, that's so smart. You know, I used to have a retractable awning at my other house. I don't need that here.
My fascination in having known you and worked with you over the years is what you've done in alternative ways, once you've built a great envelope, to heat and cool it. And you've done some really good things here that aren't done commonly. You have a ground source heat pump system, so I'd love to hear about that. And then I'm going to ask you about how you went about sizing it, because that's part of the beauty of what you do with your projects.
Ground source heat pump is the most efficient system that the EPA determined that many years ago. That ground source heat pump is the most efficient way to heat and cool any building that there is.
Tell me a bit on this one. How did you choose to install the system as far as the bore field went and some of those details?
In order to size any kind of bore field for any system, you really need to do a good heat loss calculation. I've worked with many mechanical engineers already over my lifetime, and they will do the heat loss calculations and they'll be double of what they really actually are.
As far as the size of the equipment.
As far as the size of the equipment.
Yep.
And so by putting in oversized equipment, you take away efficiency. It's like taking your little car and putting the biggest motor you can stuff under the hood and punching it at every stop sign.
Right.
That's the same effect.
What's the size of this system approximately as far as the tons?
2 ton.
2-ton cooling. For a home, how big? 28?
There's 1,970 square feet per floor.
So a 2-ton system. I've done enough load calculations, I bet software I would use say at least, even with your good envelope, at least a 4-ton is what I bet I would have gotten from the calculations.
That's
Am I-
what, right.
about
That's
right?
that's what the software comes up with.
Yeah. Then for safety, you needed the ERV. So tell me about some of the cool design features you have built into this house, how you have air moving through this home, especially underneath the basement floor deck and some things like that. But
We have a unique situation here where we had some expansive soils. And so we have a foundation that is lifted actually 6 feet off the dirt. And it sets
wood
on
floor,
stilts.
right? Yeah.
No, it's concrete.
Oh, concrete, okay.
It's concrete,
Okay.
and it's lifted 6 inches off the dirt.
Okay.
And so we got a void space under there. In that void space, I have airflow that is connected to the HRV. And so we have constant temperature air from the mechanical room, which is where warm stuff is, water heater, furnace, things like that. So we pull that warm air from that mechanical room where we really don't need it, and we pull it underneath the slab, and we pull that stale air underneath the slab with all the radon and all that wonderful ugliness that happens down there,
Soil gas
and
or
we dissipate it outside.
So the ERV itself that you chose, who was the manufacturer, why'd you choose it, and then how do you have it ducted in and around this home?
It's actually a Brown HRV,
It's an HRV. Yeah, it's a
and
heat
we
recovery
have
ventilator.
we choose the HRVs because once you seal up something this tight, and Mama starts cooking for Christmas and making a hell of a bunch of steam in the house or whatever, you need to dissipate that moisture.
Right.
And so that's why we chose the HRV. And so we have sensors in each one of the bathrooms, the laundry room, and the kitchen. That's where you make your pollution mostly. Doing laundry, doing cooking, going to the bathroom, taking showers, whatever.
Right.
And so the HRV runs at a continuous flow of like 68 cubic feet per minute flow to keep the air fresh in the house. Once you step into a bathroom or the kitchen or laundry room, it'll ramp up to 200.
So Wes, as an accountant, I love this about you. You've been tracking the data on your utility bills and tracking how your solar PV system has been performing.
My other home was about half the size of this one, maybe a little over half. But that house had about a $100 a month average utility bill. And this house in 2019 had a utility bill of about $260
For the whole year.
for the whole year.
That's fantastic.
And I get cooling in the summer, whereas the other house was hot in the summer.
Tell me a little bit about this, electric air source heat pump water heater that you put in.
It comes from Germany. They have been using them in Europe, in Japan for 25 years.
Right.
Because their electric rates are 3 times as what ours are.
Right.
And since we were going all electric in this house, I explored quite a few different manufacturers, and I came up with this system, but they don't sell the airflow kit in this country.
Okay.
They only sell the water heater.
Okay.
And so we had to make up our own airflow kit.
And the airflow kit, just to interrupt, it's because
Was
an
a
air source
booster
water
fan.
heater. Okay, it's a booster fan?
All it was a booster fan, a very noisy, holy crap, hold on to your hat booster fan. There's a high return at the ceiling.
Right.
We're pulling the warm air off the ceiling where you never heat it.
Right.
In the summertime, you're getting radiation through the insulation even.
Right.
So you've got all this warm air stacked at the ceiling.
Right.
And so when the water heater needs heat, it starts pulling that warm air off the ceiling, runs it through the water heater, extracts 6 degrees of temperature, and deposits it into the
Water.
return of the furnace.
Oh, okay.
There's refrigerant coils that go around the tank in the water heater, and so that's how it exchanges the heat.
All these things are amazing, in my opinion, in this home. And you've built an all-electric home that is affordable. Tell me a little bit about why you did this. Why an
To
all-electric home?
prove that it can be done.
Okay. Because people are saying they're telling you you couldn't.
Everybody says that in order to do what we're doing, it's going to cost several $100,000 more.
So Wes, you've shared enough with me over time that we've known each other about how you care about many big picture things, whether it's connected to your church, things with working with underprivileged youth. Seems like that's part of your decision making in getting this home. Am I right?
You're right. I hate to admit that, but yes, you're right. That was part of the decision making with the home. I've always felt like if you could use less resources, you're going to help the environment. And I went to an energy conference at the First Universal Church, at First Universalist, I think it is, and really learned more about the impact that using energy here has in other places, in poorer countries. And so didn't realize how much of what we enjoy hurts others when we're irresponsible about it. So that also had an impact on my decision to do this, because I didn't need a house. I had a house, paid for, I was retired,
So value is beyond the
Beyond
ledger
money,
sheet.
I know. I'm probably going to lose my CPA license. But yes, there are valuable things besides money. There's people's lives and their well-being.
I'm deeply impressed by the passion of this builder and this buyer to have high levels of sustainability in this home that is attainable for middle-income people in our country. Remember seeing me drop my set of keys at the beginning of the story? When performing a blower door test, the HVAC system and the domestic hot water system has to be turned off. I leave my keys on the floor so I remember to go back and turn the systems back on. I don't want to leave a homeowner sweating or freezing or without hot water after I leave. Well, we've tested Wes's home, and now, so I don't leave him in a home that's going to eventually start warming up, we're going to turn the cooling back on for the house. There we go. So, the house actually cooled down by a degree while we were operating the blower door, which is pretty fascinating. Wow. Thanks to Wes for allowing us in his home and sharing some of the wonderful design features, and to Con for taking us through his thought process. And thanks to both for sharing their why behind sustainable living. Up next, we're headed to a multifamily project currently under construction to get a first look at their sustainable design elements. Come on, let's go. This multifamily project is going up right now in the city of Longmont, Colorado. It has some very cool design and specification features which the performance consultants, Cody and Lisa Farmer at Mainstream Corporation, and the developer, Gary Kinsey, are really focused on getting the thermal envelope, that's the air tightness and the insulation values, to be far closer to the Passivhaus performance than mere building code. Let's hear their whys, and let's go check out this great building under construction right now. Mainstream Corporation's office is a converted barn in the shadow of Long's Peak. It's turned into a Passivhaus compliant building because of a sealed envelope and a mechanical ventilation system that purifies the air. Find out just how quickly the air is purified later in the program. The two of you are doing some amazing things when it comes to making buildings more airtight, encouraging the whole Passivhaus standard. Why are you leaders in moving this forward?
I think Lisa and I, founded Mainstream to make things better, to fix things that we saw that were wrong. And so the why is simply because we see that the current building stock is wrong, and because we have kids, we're building for the future for them.
You guys have several projects, but we're focusing on this under construction Greenspire project.
Yeah, the owner's amazing, and it's a project that lit up Mainstream's interest level.
When I met Cody, he enjoys this, and when he saw what I was doing, it just excited him. He was just all for it.
Finally, we had somebody who was receptive to the science, who asked the right questions, who was doing it for the right reasons.
On this scale.
Right.
Probably something that really made me work on it hard is I told a lady at our church that it was impossible to build a 450 square foot unit that was just, the restrictions would be so great and the expense would be so great that it just was impossible. She got a project through the city called the Micah Homes that are affordable, through a group called the In-Between, which provided that type of housing.
Transitional from homeless into some sort of housing?
Right. So she did so much to help affordable housing. She broke the mold because mine are 300 square feet, and when she started, the city required 450. So she has helped, and so this is my, this was something that I needed to do for her.
Is this project going to help people coming from homelessness into transitional, or is this meant to be more of a market rate,
We are tied in with the city with 10 affordable units that meet, that we have to meet certain requirements. But because of the way they're designed, only 300 square feet, they are all well below the city's requirements. And that is the secret to affordability. Is its size.
It's the size.
Well, at the original, 2.5, 3 years ago, 450 down to 300, that is, that's 30% smaller. And that lowers the cost 30% for rent. Its size is a factor. I didn't have 44 of these built without knowing what one looked like. So I built one in my basement. I built this unit in my basement.
That's awesome.
Because you just don't want 44 of them there.
And so you tried it out how it would feel to live in that, right?
Yes, yeah. So, we had several principles. It had to be viable economically and investment-wise. It needed to really do something about the homelessness. And to me, it had to be 21st century. The code is so far behind and technology is moving so fast ahead.
I have to interject is that you, at one time, were a building inspector, correct? So you know the code really well.
I spent 11 years in code review and stuff like that, and building inspection, and it just wasn't. It's not keeping up. So I wanted a 21st century building and renewable energy. I do not want to face my grandchild knowing the mess that I've left him. I'm responsible. No, you're responsible.
We're responsible.
We're all responsible, and we've, I've got a few years left. Maybe I can correct a little bit of it.
Now, before meeting Cody and then Lisa, had you heard of Passivhaus before, or had you not even heard of that previously?
Not Passivhaus.
Right.
Passivhaus has its own modeling software. Passivhaus Planning Package is how it started. Internationally, they still use it. And then with all the climate zones in the United States Passivhaus Institute created Woofy Passive. So that's the software program that I've...
What does WUFI stand for again?
Oh,
it's
good
WUFI.
Yes.
I'm sorry, but it's in German. It's in German, right?
Yeah, it's probably safer if we just spell it and leave it at that. It's a hygrothermal model that's parametric and is attached to the elements of Woofy Passive Modeling Program.
So it does what other manual J softwares do as far as heat load calculations, but it's more accurate. It takes air tightness seriously. It incorporates internal heat gains. A lot of just, when you get down to the micro loads, this is the software that we should be using.
She likes gritty and language and spreadsheets and fancy graphs, and she's very good at it. But beyond that, she gives our clients an opportunity to just ask anything they want about their building. For example, what if we switch the insulation because this insulation is more friendly to the environment?
Right.
Or this insulation is cheaper and I can use it recycled form.
Right.
And all those questions can happen at a phone call away.
So Lisa, you've told me rules of thumb for Passivhaus, the idea of an R40 underneath, an R50 on the walls, R60 for the ceiling or attic. For Greenspire, you're really close to that, but what'd you end up using and then why?
We are very close. We're about R38 where the floor meets the crawl space.
Nice.
And then the walls, we did push for a little bit more rigid insulation than we got, so we landed at a R30. Okay. We have 2 inches of rigid foam on our framed walls.
Nice.
And then the roof itself is a R60 as well. And then each of the units is airtighted itself from each other.
Trying to stop the smell of people's food drifting over to that place next door.
Yes.
Very nice.
Lots of design meetings taking those details into specific consideration.
This team has already done more on this airtight detail than you'll see on the average construction site. We'll come back in here and button it up even tighter because we want Passivhaus air tightness in each of these 300 square foot units. So a quick air barrier inspection that Mainstream would do would be to come in and see what is the continuity of the air barrier. And that means is everything connected properly on all 6 sides of the building or the area that we're in. So move on over here. We use Proclima vapor open tapes, and the reason is because people sweat and they breathe and they cook, and so we don't want anything getting trapped in our walls.
And then the walls, you got 2 inches of rigid, so XPS, is that correct on the outside?
EPS.
EPS, okay, yeah, so expanded polystyrene on the outside, so
Yes.
good. So that's like about an R8, is
Yeah.
that okay on the outside? Then what do you have in the wall cavity?
Cellulose.
I think the cellulose argument's a really good one. And that's something that can change in the field. I mean, it's common that as Passivhaus will spec cellulose or something and we'll end up with blown-in fiberglass or something.
Okay.
We like cellulose because it's a recycled material and it's very anti-rodent and buggy.
I agree, yeah.
But we'll see what that...
Fiberglass, rodents don't have a problem with, but cellulose, they don't like it, the borate that's on there, yeah. So that's good, yeah.
But dense packing it in, then it'll surround all the wiring and everything, which is why, it's very tempting on this, you'll see bats in normal situations, go in and slap them in, but then you have little air pockets, and that's the other part of our science is we don't want any air pockets in any of our assemblies. This is how we do it.
Yep, that's excellent.
And then for the windows, actually.
Yes, yeah, for the windows.
We started
So
with
U-value.
Alpine in the design process, but then now we have Gherkin windows in there. They are less than 0.2. This one's 0.5. It's fixed. The operable one
1.5, yeah.
is
0.17. Those are excellent windows. Like Energy Star in our area requires about a 0.3
Yes.
approximately. So a much
less
better
than
window.
0.2 is where we're targeted.
And it's a double pane. So here again, the collaboration of Mainstream with the clients, you learn things from your clients. So it's very good to be open-minded in their team. But and we went from a fiberglass to a UPVC, and the budget was significant enough. The other thing that we
That's
learned...
for the framing of the window?
Yeah,
okay.
UPVC versus Alpine's fiberglass.
Okay.
We got double pane, so you don't always have to go triple pane to get the low U value or the high solar heat gain. So the technology in the windows and the availability of those products is happening. So Gary found that golden nugget.
That's fantastic.
And do you know, with all of this, we were almost certifiable for Passivhaus.
Yeah.
The heat load is the one that I kept fighting, and I couldn't really like nail down how to lock it in. But even the primary source energy, we meet the threshold for Passivhaus criteria under 6,200 kilowatt hour per person per year.
Right.
And that I will attribute to the solar hot water.
Okay. One thing I'd like to ask was about a technical detail in the project, the solar water heating parts of it. Some people think that's an older technology, but boy, it's working for your project. It's going to work for your project, as I understand it.
Well, you're correct. It was old technology, and I'm kind of, it's old technology. The inspiration came from the fact that the number one heat load in those units is hot water.
Okay.
Now, I also knew that I could use renewable energy through the city and my own solar, and I could just pay for the resistance heat. But when you started looking at the hot water that comes out of the shower and goes down the drain and is gone, was just amazing. It just way too much, and so we attempted to recover that. There's no designs. You have to think it up yourself. And then again, through Cody and Lisa, the solar hot water, solar thermal, and when we got the information on that.
And so we introduced Laurent Malone
Yep.
from Capital Solar.
Solar.
He's a great French accent. He's a super intelligent, wonderful guy.
Yep.
He was perfect for the project.
Yep.
And honestly, that introduction was like exactly what Gary needed was, hey, this is that cherry that's going to take this project from an almost to something else.
Yeah, and that's what's beautiful is the pairing of a great envelope, and then simpler mechanical systems, and then bring renewables in. Like you said, is really what helps on that carbon footprint side. Energy use per person side. So that's beautiful.
So this is a huge negotiation of using like off-the-shelf, cheap resistance heat. But wait, if we go this cheap, we can afford this huge solar thermal system that's going to do all the heavy lifting anyways.
Yeah, so that's a great way, and it takes smart people, educated people working with smart, curious, educated builders and developers, to make that happen. One of the smart ways Gary is preparing for the future of electric utility policies is by placing demand control meter boxes in each unit.
In the future, every place will have a demand meter. Throughout all units, each unit has one of these. It will shed loads to keep the total demand below a certain level and probably save as much as $2,000 a month.
Well, one of the fun things I would think we found on this one, I mean, we go back and forth trying to get it to be this certified Passivhaus building, this apartment building, and it fought back. The resistance was hard and the force was windy and all this stuff. But what we learned was that multifamily is a lot easier to take Passivhaus to certifications. Every time we have the opportunity to take one to the mat or to take one full passive, it's always like, well,
We run it through the gauntlet.
Yeah, run it through the
Full
gauntlet.
ringer.
This one has bothered me just because, you want it to be certified. Colorado needs it,
We need a multifamily.
we would like to be the company that helps make that possible. But on the same token, it's an amazing building. It's almost passive. It's got all the big passive elements in it.
It's going to serve a big need.
I'm dying to do another one because there's just so many things I'd like to do just a little bit better and get to that Passivhaus in a little past. Because I see that just with a little bit of thought, you could hit that every time easy.
Yeah.
And I'm excited about that. But not till this is done. I gotta get this one, on the books.
It's amazing what purpose can do to you in the morning to get out of bed and chase it. And I will tell you that when you're in a Passivhaus or you're in a space like this where it's very comfortable and even and it nourishes your soul, it's purpose. Some people find purpose in money, some in family. I certainly do in family. But beyond that, it's making the world a better place, fixing something that is broke.
Remember when we wondered just how quickly Mainstream's Passivhaus office purified the air? Let's let Cody tell us.
Almost half the room is purified within 1 hour without hearing it.
Yep.
Thanks for bringing that up.
No,
Yeah.
it's wonderful. I hope these stories have truly inspired you as much as they've inspired me. I look forward to seeing how Cody, Lisa, and Gary's project comes together and revisiting them for an update after residents have moved in. I also look forward to meeting and interviewing other creative designers and builders and developers who apply the cutting-edge designs shared in our videos to create more and more regenerative structures until they become the norm rather than the exception. Also watch the technical side of each project in our accompanying video and see the documentation on the Heart of a Building website. We look forward to sharing more stories like these because buildings are one of the very few things we build which last longer than a human lifetime. Many of us understand the first half of the equation, building a profitable structure which provides shelter. But exploring the other half, the why behind the design, blends our hearts with the wisdom of our minds to create buildings of the future today. See you on our next episode.
My name is Steven Stanek-Scott. I am the construction director at Habitat for Humanity, the St. Vrain Valley in Longmont, Colorado. We build affordable housing. We try to do that for the people that are in our community. When we think about affordable housing, typically you only think about the mortgage as the cost of a home. But what we really have to realize is that the cost of a home is the mortgage, the property taxes, and the energy bills. About 10 years ago, we really started looking at energy efficiency in the construction of our homes, looking at things like LED lights and energy efficient appliances. But then we looked really deeply at what we're actually using energy in the home for. And that was keeping the home comfortable on the inside. So heating and cooling the house is what you use the most energy on. So we started off by really trying to seal the home up, and we did that with volunteers and tubes of caulk. So we went through the house and we were very diligent and deliberate about closing off any sort of openings that we could find anywhere to the exterior with caulk. Most commercial builders don't have the labor force that we do. Since we do have a lot of volunteers that come out, many hands make for light work. So we can really get lots of people involved in the energy efficient practices of just using that caulk to fill every little gap and crack. Once we got as good as we could get with caulk, we wanted to take another step forward. So we started using a higher grade of insulation. We use a closed cell spray foam insulation in the walls. And that is a product that goes into the wall and it expands. So it finds every single little gap and crack that you could possibly imagine and seals the house up for a really tight house. So when you have a really tight house though, that can cause other issues. So then we started to think about indoor air quality, and indoor air quality became really important. So we started using all hard surfaces for floors, no carpet. We started using all low VOC products inside the house, so paints and stains. We also have continuous ventilation throughout the house, so that's air that's being pulled out of the house and the new air being brought into the house through fresh air. And that just makes for the indoor air ups the indoor air quality, but it does it mechanically, so it doesn't take away from the efficiency of the heating and cooling system. These homes that we're here at, they are actually going to be our first all-electric homes. We are able to go to all electric, including heating and cooling, because of those energy efficient heating and cooling practices that we talked about. The benefit to getting away from gas is it's one less utility cost in general for the homeowner over a long period of time, but it's also one less cost burden on Habitat to actually bring that utility to the home. So these houses have all electric heat pump mini split technology on the inside, which actually heats the house in the winter, and it cools the house in the summer. So it acts as both heating and air conditioning. We're actually planning a solar project. This is kind of a test case for us here on at these homes in Longmont. We're going to be doing a new type of solar that is actually in the ground. It's going to be lined into the sidewalks of the houses. The solar system itself will actually only provide about half of the energy that the home needs total, but they will still be connected to the grid, so they'll still be able to use that electricity, and the solar will just continue to offset their utility costs. If you want to come out and learn how to do this stuff, feel free to come out and volunteer with us anytime. We work every week, Tuesday through Saturday, and we will be glad to teach you a little more about how you can even make your own home more energy efficient.